Hello everyone. I am Shreya, Assistant Professor at ABES Engineering College, and in this presentation we will see about cryptography. So we will start the session with the content shown in the presentation. Firstly, we will discuss what is the basics of cryptography. What is the basics of cryptography means, and what is the definition of cryptography, why we need cryptography, then we will discuss what are the different types of cryptography and explain them with the help of an examples and the key components which are required during cryptography process. And at last, we will discuss what is the benefits of using cryptography. So, before learning or knowing what is cryptography, we should discuss why we need cryptography. What is the new need of using cryptography in computer system security? So, in normal language, we can say that cryptography helps to keep our information secure, and it provides a secure communication in the presence of any other third party. This can be explained with the help of an example. Let's suppose a person A wants to send some information to person B. He wants to send or exchange some data in between himself and the person B. Then it should be known to any, then it should not be known to any other person. It should be known only for the person B. So, cryptography is needed to protect the data and users by ensuring their confidentiality and prevent them from any cyber crimes from by intercepting sensitive corporate informations. So, now let us discuss the definition of cryptography first. What is the cryptography? So it is a method to protect any information and communication with the use of various codes and mathematical calculations, so that only those for whom the information is intended can read and process it. And this can be understood easily with the help of an example of a diagram. So in cryptography, we take a plain text as a input, means the message which a person wants to send to other person. Here a new term, encryption algorithm, is added. Encryption algorithm which is added, and the work of this encryption algorithm is to convert the plain text which is taken as the input of the cryptography. It is the work of encryption algorithm to just convert the plain text into some cipher text. And one another term is used here which is called as decryption algorithm at the receiver side. And the work of this decryption algorithm is to convert the cipher text into again a plain text. So this is the process of cryptography where a plain text is converted into ciphertext by using encryption algorithm. And once again at the receiver end, it decrypts the ciphertext into the original plain text. And this is the cryptography process. But here the two terms is used. First is encryption algorithm and decryption algorithm. Here both of these algorithms uses two inputs. One is the plain text. It means the original message which a sender wants to send to another person. But here encryption algorithm uses two inputs. One is the plain text and another is the key. And this key is the another input of this encryption and decryption algorithm. And it depends, and the security also depends on these two keys which are provided as an input to the encryption algorithm as well as the decryption algorithm. And the converted ciphertext is, what is ciphertext? It is just a coded form which is used to convert the plain text so that it can't be readable to the third person. So here encryption algorithm uses key for this function to make the data secure. So This is the cryptography process where an encryption algorithm used as a plain text and the key as an input to convert the plain text into ciphertext, and once again the decryption algorithm used as a ciphertext as an input and with the keys to decrypt that ciphertext into the original plain text. So this is the process of encryption. We can say that if a person wants to send some information to the person B, then it have to use cryptography just to secure her data or his data from the other third party. So now let us explain this more with the help of an example of cryptography and its types. So mainly cryptography has two types. One is symmetric key cryptography and another is asymmetric key cryptography. And this both the cryptography includes and both the types of encryption include a key and a plain text as a input. So, symmetric key cryptography definition says it creates a fixed length of bits known as a block cipher with a secret key that the sender uses to encipher the data and the receiver used to decipher it. So, the process is the same of cryptography, but the main feature of here is the key, which we are using as in the encryption algorithm as well and in the decryption algorithm as well. Let us discuss it with the help of an diagram. So here we have a plain text. This is converted into ciphertext with the help of encryption algorithm. And this is decryption algorithm, which is used to convert the ciphertext into plain text. So in symmetric key cryptography, the key which is used to encrypt and decrypt the data are the same keys. Let's suppose if the sender, this is the side of the sender. So let's suppose this sender is A and this is receiver B. Here, the sender A is sending the plain text message to the sender B. So he will use the key and let's take example of key as 100 value. It means the key here is used the value as 100. It means at the receiver side also the same key value is used. It means this encryption algorithm, if the encryption algorithm is using a key value 100, then it should be same at the receiver side also. It means the decryption algorithm should also use the same key. Like here the value is 100. It means if this encryption algorithm using 100 value, then the decryption algorithm should also use the same key which is 100. Then it is possible to convert this plain text into ciphertext and again to ciphertext into plain text. So here both the keys value are same. So this is the key point in symmetric key cryptography, that both the keys from the encryption algorithm side and the decryption algorithm should be same. Then it is called as a symmetric key cryptography, and it is also called as, or it is also known as a single key cryptography. Why? Because here the key values which are using by both the sender side and receiver side are same here. So this is the symmetric key cryptography, and it is also called as a block cipher. It is also called as a block cipher. Why? Because it is using a block chain of using just to convert the plain text into ciphertext and ciphertext into plain text. So, and the one of the best example of the symmetric key cryptography is the advanced encryption standard, which we will discuss in the next video. So here, this is the symmetric key cryptography. We have to keep in mind that if we are asking about symmetric key cryptography, then we will use the same key. But another type of cryptography is asymmetric key. In this, we don't use the same key. The receiver side and the sender side uses two type of keys. One is called as public key and another is called as a private key. So let us explain this. Let us understand this topic with the help of the same example. Let's suppose here sender A wants to send some message to sender B, receiver B. Here in symmetric key cryptography, he is using the same key value as 100. But in different type, in asymmetric key, here this key is known as public key and this key is known as a private key. It means in asymmetric, we are using two keys, one from the sender side and one for receiver side, but here the values are not the same. Let's suppose we have taken the example of value as 100. Let's suppose here receiver side encryption algorithm is using public key as a value of 100. But when we will see in asymmetric, the value of the key which is called as a private key used in decryption algorithm will use different value. It will not use the same value which is 500. It will, let's suppose it takes value as a 500. Then we should keep in mind that if we are taking different keys, but it should not change our actual message. Let's suppose here plain text is using 100. If we are doing some mathematical calculation, what is encryption algorithm? It uses some mathematical calculations or codes to encrypt this plain text with using as a public key 100, and this public key is visible to everyone, also to the third party also. But the main security depends on the private key, which is known to only sender and receiver. Let's suppose here sender A knows the private key and sender B is the only one who knows the private key. It means when the encryption algorithm is used, it use the value as 100 of the key. It do the calculation according to the 100 values. But at the receiver side, when the cipher text is converted into plain text, this decryption algorithm uses 500 as a value of the keys. So we should keep in mind that if we are using different values, the main result should not be changed. It can't be changed. The value should remain same. It means when we convert the cipher text into plain text, it should be the same as the original message. So it is the main difference between the symmetric and asymmetric cryptography, that the keys are different in asymmetric. So same is written in this presentation. It is a process which uses a pair of keys. A public key which is associated with the sender for encrypting message and a private key for decrypting the message. There are various examples of asymmetric key cryptography which are used in cyber security. So, the most popular example of asymmetric key cryptography is the reverse Samuel Edelman, which is commonly known as RSA. Another example is DSSS and ECC, and these are the different types of asymmetric key cryptography which uses a pair of keys to just encrypt the data and to decrypt the data from both the side, sender side as well as the receiver side. So this is the main difference between asymmetric and symmetric key cryptography. So let us move to our next topic, which is the key components of cryptography. What are the key components of cryptography? Here we have seen the plain text. What is the plain text? We can say plain text is the original message which is readable, which can be readable to the persons. It can be a message or in the form of data which can understand by anyone. And next is a cipher text. We are using the word cipher text again and again. So we should know what is the cipher text. Actually, cipher text, it is a message or data that is not readable. It is in the form of codes which is applied on the plain text so that it can't be shared, it can't be understandable to the third party or to the attacker who want to know the who wants to attack on the plain text, who wants to know the message or data which are communicating in between two persons. So this is the cipher text. It is accomplished by performing the encryption as standard, or you can say encryption algorithm on plain text using an encryption key. And the next is encryption algorithm. As we have already discussed, encryption algorithm uses two as inputs. One is plain text and another is key. So it is used some encryption techniques to convert the plain text into some ciphertext form at the sender side. But decryption algorithm, what is decryption algorithm? It is opposite to the encryption algorithm. It is used from the receiver side where a ciphertext is converted into plain text. Again in the plain text so that it can be readable to the receiver. And at last, we have discussed what is a public and private key. It is a pair of keys which is used in the asymmetric cryptography, where public key is known to everyone, although the sender and receiver both know the public key, but the third party can also know the public key. But the private key is private in between the sender and the receiver, and the message can be only decrypted if the receiver have the same value as a sender sent with their message as a private key. So these are the components of cryptography. So it can be explained with the help of this diagram. As here we are seeing that there is a plain text. Plain text is taken as an input to the encryption algorithm, and here is we are using public key, and we can take various public keys. Like here we are using A, B, C, D. These four values can be a public key. It means it can be any key which is used in this process, in this cryptography process of encrypting the plain text into ciphertext. But we are seeing here at the receiver end, there is only one private key. Like here, private key is C. So this decryption algorithm using ciphertext and the private key as a input so that it can convert this ciphertext into the plain text. So it is the whole working of a public key cryptography. It means it is a working of asymmetric key cryptography, which is commonly used in cybersecurity or any computer system security to make our data secure from the third party or the attacker. At last, we will discuss the benefits of cryptography. What can be the benefits of cryptography? So, herely the benefits can be explained with the help of the four principles which is compulsory in any security form. Let's suppose first one is confidentiality. In confidence, it means it refers to the certain rules and guidelines usually executed under confidentiality agreements, which ensures that the information is restricted to the only person, to certain persons who wants to interact or who wants to share the information. So it means cryptography deals with the security of the person or the places. It should be restricted. If a person A wants to send some message to person B, then it should be in between these two persons only. No other person can know or can interfere in this communication. So this is the one of the most important principle of the cryptography. Next is data integrity. What is integrity? Data integrity is refers to maintain or make sure that the data stays accurate and consistent over its entire lifetime. If the person is sending some message or some value, let's suppose he is sending 100 as a message, then it should be received as 100, although it is using encryption and decryption method with the help of keys, but the value should not be changed. It should be same as the original message. So it means the data should be accurate, although we are using many mathematical calculations in for performing encryption or decryption algorithm, but it should be the same. The value should be same. If it is sent as 100 from the sender side, then it should received as 100 to the receiver side. So this is the benefit, or you can say this is the principle of any cryptography performed. Next is authentication. As its name specifies, authentication means data claimed by the users belongs to it. It means the data which is belongs to anyone, it should be for them only. It can't be taken by the third person. So here, this is the authentication portion which deals with the user belongings. Next, at last, is non-repudiations. It means it refers or confirms that the validity of the message. It should be, it confirms about the validity of any message. It ensures that someone cannot deny the validity of something. If the value is given, then it can't be invalid. Okay. So it refers or confirms about the validity of the data or the message sent between sender and the receiver. So this is the basic cryptography, its types and difference. Thank you so much. We will see in the next video. Thank you.